Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 12, Section 10, Composite Events, Probability of Composite Events. And in this video, in particular, we're going to be taking a look at what happens when you find the probability of two dependent events. So these are events that depend on each other. In the previous video, we talked about dependent events. In the previous video, we talked about independent events. So we used the example of a bag with 8 marbles in it, 2 green, 4 blue, and 2 red. And I wanted to know what was the probability of pulling a green and a blue marble. Not a green, then a blue, but a green and a blue. Okay? So what we said was you would find the probability of the green, find the probability of the blue, and then you would multiply them together, and you would get 8 out of 64. Or a 1 in 8 chance. Okay? So, in this video, we're going to talk about dependent events. As you can tell with the independent events, one event doesn't affect the other. So typically with an independent event, your denominators stay the same. Your numerators aren't affected. The first fraction doesn't affect the numerator of the second fraction, and the denominator doesn't change because whatever you're taking away in the first event is being returned in the second event. So for example, when I pull a marble out on my first pull, before I do my second pull, I'm putting the marble back in. That's an independent event. In a dependent event, it changes. In a dependent event, if I do my first pull, I don't put the marble back in, so it affects the probability of the second pull. And so that's really the only difference here. Everything else is exactly the same as far as the process goes, but in this case, if I pulled out a green marble first, and then the second marble, the blue marble, there would still be 4 blue marbles in there, but there would only be 7 marbles in the bag. So now my probability changes, and it's no longer going to be 1/8. Instead, I'm going to have 8 over 56, which is 1 over 7. So that changes it slightly. Other than that, everything is exactly the same. The explanation for why this works, for why this finds us the probability, it's exactly the same. I have 8 choices overall. So total, I have 8 choices on my first pull. On my second pull, I have 7. So there's a total of 56 choices or outcomes that could occur. I'm looking for favorable outcomes. I'm looking for a certain outcome. So I started off with 2 green marbles, and then I was looking for one of the 4 blue marbles. So there's a total of 8 different outcomes where I get a green marble with a blue marble. So I could have green marble A with any of the 4 marbles from blue, and green marble B with any of the 4 marbles from blue. So there's a total of 8 different possible outcomes there. And there's a total of 56 altogether. So I have an 8 out of 56 chance, which is a 1/7 chance, which is roughly 14% if you want to divide 1 by 7. So the other way you could have done this, there's always 2 ways to do a dependent event. In this case, the green marble was pulled first, which affected the pull of the blue marble. You could have done it the other way around and done 4 8s. Okay, so there's a 4 out of 8 chance that I pull the blue marble, which would then leave me a 2 out of 7 chance for the second one. So as you can see, the numerators aren't affected because this represents green and this represents blue. So if I pull a green, it's not affecting the blue. Okay, numerators are the same, denominators are the same, so we still end up with the same probability. So it doesn't matter if you're pulling green or blue first. Okay, we're not worried about that. I just want a green marble and a blue marble. Okay. Now I'm going to go over one more example for a dependent event because we haven't discussed this yet. What happens if I want to pull both of the green marbles in a dependent event? Well, I I have a 2 out of 8 chance to pull the green marble the first time. Now, on my second pull, both numbers are going to change, and I'm going to have a 1 out of 7 chance. Because I have one less green marble in there, and there's one marble less in the bag. So bottom represents the number of marbles in the bag. Top number represents the green marbles that I'm looking for. So on my second pull, there's one less green marble, and there's one less marble in the bag because that green marble's now been removed. So I would now have a 2 out of 56 chance. Or a 1 out of 28 chance to pull both green marbles out. Okay? If there are any questions on that, please let me know. Pause the video, take good notes. But again, the explanation for why it works is the same as the independent events, and it's just a matter of finding both probabilities and then multiplying them together. Tune in for the next video on mutually exclusive events.